Un reportage en direct de Mars, c'est presque le cas. Ce prototype de rover ne se trouve bien évidemment pas sur la planète rouge. Il est en Italie, à Turin, au pied des Alpes, chez l'industriel Thales Alenia Space, et plus exactement à l'Altec, un centre technique qui associe l'industriel, l'agence spatiale italienne et des institutions de la région de Turin. C'est d'ici que sont, par exemple, surveillés les modules de la Station spatiale internationale fabriqués par Thales Alenia Space, ce qui représente tout de même la moitié du volume habitable du complexe orbital. L'Altec possède aussi cette simulation de terrain martien. Le but, mettre au point les technologies du premier rover martien européen, Exomars.
What are we doing here in Torino is in fact prepare the way for the future exploration of the red planet. We are priming for the European Space Agency a joint project with NASA which is called Exomars. The goal of Exomars is to land on Mars and to find possibly a trace of life, whether it's present or past life. To do it, what we need is the capability of moving on the planet, which is a capability already given by some of the past missions made by NASA. What we have added as European is an additional capability, which is the third dimension capability, which is just to get down to the soil of Mars up to 2 meters, pick up samples, analyze samples, and send the data back to the Earth. This is a complex process, firstly because it's technologically a challenge by itself, but also because we don't have a possibility to control in real time from the Earth. The system will need to have its autonomy. You have to keep in mind that to send a command to Mars and to get back a reply is going to take something like 12 minutes. So therefore you cannot rely in this time that nothing is happening. So that's why what you can see just behind me, the rover, it has something which looks like 2 eyes. Instead it's a panoramic camera. And in fact this allows the system to make sure where it is and what kind of decision it needs to make, as I was saying before, just to overcome any potential problem. These information are flowing to a computer, and the computer makes the decision. Of course here is ground stuff, it's not a real flight hardware computer. You can see also that the system is based on 6 wheels system. One peculiar part is that the shock absorbing system is made by the wheel itself. So we have no shock absorber at level of axis, but we have a shock absorber at the level of the wheels themselves. In addition, this system is able to move like a crab. This is because, of course, we don't know what we're going to find where we land. So therefore, the system needs to have this maximum flexibility, let me say, to escape from a situation in which just going straight on or backwards could not be a solution. The dimension is actually the one you see from the external. It is not smaller or bigger than that. And the drill, which is in fact the machine who's making the hole, is going to be mounted as well here. But let me now just show what we are doing also. You can see the machine which is working as well. It's a commercial one in which we are experiencing some of the major algorithms that deals with autonomy. What we want to do, and we are doing with this, is to look at the future. The future is rovers that are able to make a decision process for longer time than Exomars does. So, and what we do is, in fact, we are focusing our activities on the algorithms that allows the autonomy to be exercised fully. Of course, you don't need complex machine in terms of locomotion hardware. What you need is build a brain for doing this.
Un cerveau informatique qui va améliorer l'autonomie de robots qui, sur Terre, accompliront des tâches répétitives ou dangereuses à la place d'êtres humains. Un exemple concret de technologie spatiale capable d'améliorer la vie de tous les jours.